Hello, everyone. My name is Aakash, and I'm thrilled to be here at the Applied AI Summit. Almost every single person today is working on deploying, building, supporting, or using systems that are smarter, faster, and more capable than anything we have ever seen before. But this capability comes with a profound challenge: the problem of unstructured, disjointed data being used to make decisions. The core problem we are going to be talking about is simple. Our risk management processes, the quarterly reviews, the gigantic spreadsheets we have been using for a very long time for software assessments, software risk assessments. We were managing systems that evolve perhaps once every 90 days. But your AI systems, it can change anytime. It can change even tomorrow morning if you decide to do something today. Yesterday's preferred filled out spreadsheets and GRC management tools or governance risk and management tools become instantly stale. That's the gap we are trying to close today. What you learn today over the next 25 minutes, we are going to cover four important topics. First, we'll go to the basics. We'll define what security risk actually means in the age of AI. I'll introduce a practical three-layered system you can use to keep pace with this continuous AI evolution. We'll look at how LLMs make this kind of continuous risk intelligence feasible today. And finally, we'll walk through real examples of rapid decisions that this kind of system will enable you to do. But to begin with, let's talk about risks. Let's go right to the basics. At its heart, security risk is about answering four simple questions. These are the same four questions we've always used, but the answers change dramatically with the introduction of AI. The first, what could go wrong? This is identifying the potential failure modes or vulnerabilities. We have done this for ages with our traditional systems. But in AI, this is more about than just bugs. It's more about model drifts, jailbreaks, emerging behaviors, new technology that we had never seen before, change the way we operate with systems, change the way we bring businesses together. That's what we need to figure out during what could go wrong. Then the next question is, how likely is it? We assess probability based on not just code, but on current conditions. We ask questions like who's using the system, how they're prompting it, how recently the model was updated. We never used to talk about models and how the systems are being prompted by users before. This is a new concept with AI. The third is how bad would it be or the impact. We evaluate the potential impact on users and the businesses. A hallucination in a fun chatbot potentially has zero impact, but a hallucination in a clinical diagnosis tool is catastrophic. What should we do next, though? That's the fourth question. We define concrete, actionable steps with clear owners. The old system, with its spreadsheets and quarterly reviews, worked when the systems and the answers were stable. But when your AI can behave differently daily, the old systems becomes a historical artifact, not a tool for prediction. Let's talk about some real world examples. I've been talking about risks, but what does it mean in terms of AI? The AI risks are very subtle. They are compounds and they are happening right now in our systems. Let's take for an example a helpful refund bot. You build a customer service bot. You give it permissions to look up orders. You give it permissions to email customers. You give it permissions to issue small refunds. Everything seems fine if you just look at it from an individual perspective. But now let's think about it from a threat actor perspective. Let's bring all these capabilities together and put in the fact that it is not managed. The combination of permission creates an unexpected loophole that people or fraudsters could use to exploit and cause fraud. Technically, nothing broke. It's what the system is supposed to be doing. But when you bring all these high critical capabilities together, they create problems. Another example could be a normal copy by accident bot. This is a popular one, and we see it very often. A support assistant doesn't steal private data, but in its output, it produces strings that look exactly like real phone numbers or social security numbers because those patterns were used in training data. It alarms users, it damages trust for large organizations, but actually, no data was compromised. The problem in this situation is not limited to confidentiality, integrity, or availability. The problem is imitation of authenticity, which hits trust. Another example is, let's talk about a threat actor trying to use outputs from a chatbot, which will help them in making or guessing behavior. Imagine a diagnosis assistant in a hospital. No medical records leave the security parameter, but the assistant's behavior, its refusals, and its specific suggestions might hint at a rare disease that was potentially in the training set. Threat actors can infer private information from such information that is produced by by the chatbot. It becomes too smart for its own good. You fine tune your data, increase its thinking time to boost overall accuracy, which is great for business metrics. But you accidentally make it more obedient to highly pushy or risky prompts, subtly increasing the security risk of an unintended consequence of an optimized charge. You fine tune your models, increase its thinking time to boost overall accuracy, which is great for business metrics. But you accidentally make it more obedient to highly pushy or risky prompts, subtly increasing the security risks as an unintended consequence of an over optimized change. Risks are dynamic, they are emergent. We cannot catch them with a static snapshot. Old risk processes are like a photo of a moving car. It's not there when you actually go to look at it again. Every day, models retrain, documents retrain, user prompts evolve, the tool changes. Waiting 30, 60, or 90 days to solve a problem or to find a problem in a system that changes daily is no longer an option. We need risk intelligence that updates when the system changes, not when the calendar says it's time for a review. We don't want a paper map of a road network. We want a real time GPS map with live training data, live traffic data. And that's risk intelligence system for you. Essentially, risk intelligence must have four essential traits. First, it needs to be continuous. It must recheck the risk profile every time a model, data source, prompt, tool, or policy changes, not at a schedule which was set 30 days back. It should be context aware. It has to know the difference between a poetry bot and a medical assistant. The exact same vulnerability is a oh well for one and a stop everything and drop everything and fix it for another. Context is king when it comes to AI driven risk or risk for AI systems. The intelligence system should be actionable. It can't just give you a number with, let's say, a risk score of 7 out of 10. It's useless. No one understands it. Or even from a non number perspective, if I say high for a risk, it's not useful. The risk intelligence system needs to provide you with context of what to do next, with clear owners and expected impacts of the action that you're doing. It needs to be explainable. You need to be the system should be able to explain you of how did it come up with the solution. You can't trust a black box to manage the security of another black box. This system must know why it came to a conclusion, citing so humans can verify and trust the reasoning. This brings us to the architecture that makes this feasible. To achieve continuous contextual actionable intelligence, we break the problem into three simple layers, like a wedding cake. The first is the data layer, the foundation. This layer takes all of our messy inputs, the tickets, logs, chats, configuration files, policy documents, and turns them into clean, searchable, and most importantly, privacy safe facts. We need to ingest messy signals and emit atomic facts. Questions like who, what, when, where, it all creates similarity fingerprints so we can find facts that mean the same thing, even if they use different words. The second layer is the intelligence layer or the map. This is where the magic happens. We connect these facts into a living map of our systems. Who uses who owns what happens and what protects what. This is where we use AI to retrieve the right signals of reality when we ask a question. This stores our living map and answers questions by retrieving a slice of that map. It emits detections when something looks off. The third layer is the action layer, the executionist. This layer translates intelligence into movement. It produces clear, specific plans, what setting to tune, who to notify, what to turn on. It gives you the next steps. Risk intelligence is of no real use to the end user until you give it instructions of what to do in order to reduce the risks. For humans to trust the system, the boundaries need to be boring and predictable. We enforce three simple contracts between these layers. First is the fact contract for the data intelligence layer. Every piece of data entering the map must have a human readable type, a timestamp, a confidence score, and a return address to its source. If any of these lack, it doesn't enter the living system. The context bundle, or the intelligence to the action. Every answer the intelligence layer provides to the action layer must include a list of systems, data classes, controls, and owners used to generate the answers, plus citations. If this bundle is thin, the system doesn't act, it acts like a human. Plan contract, or the last contract between the actions and the people. As we were saying, every risk needs to come up with an action plan. Every action step must have a priority, a target system, an expected effect. Like if you do X, it's going to reduce the risk by Y. It needs to provide that context as to why you want to and need to do certain actions. And it should always come up with a human in the loop where the human does the review of the action plans. We are not at a stage with AI yet where we can 100% trust the intelligence system to ensure that the context is not missing. We need to have the human in the loop. These contracts are what makes the system explainable and trustworthy. We do not want a system which just does things in a black box and expects us to believe it. Let's dive a little bit deeper into the three layers. How do we build the data layer? You have to be ruthless about simplicity. You need to make it as simple as possible. We begin by picking a tiny set of facts. Let's say 6 to 8 facts maximum. Which systems, what data type, who owns it, what happens, when, confidence, source, etc. If you can't explain each one to a manager in a single sentence, it's too complex. We don't want to include it in the intelligence system. We need to make privacy non negotiable right from the start. Anything that resembles personal identified information gets hidden. It needs to be anonymized or tokenized before analysis. You can still see patterns and manage risks without even passing raw data into the system. We need to normalize plain language. We need to create a simple one page glossary, define terms like customer, data, app, owner teams. If people argue about words, they won't trust the numbers. That's the reason why we set ourselves to success by defining what risk means. Similarly, we need to do it for all the terms that we need to include into the system. We need to attach a return address and confidence. Every single fact links back to its source log or document. This is your explanation foundation. This is how you explain how you came up to a consensus of the next steps of the risks that you identify. And the last is track your quality signals coverage. What percentage of your total systems have your core facts? And disagreements where things went wrong, where people did not agree with your analysis or the system's analysis. Rising coverage plus failing disagreements equals success. Okay, this is a living map. We should start small. Start with a tiny legend. Define just five types of nodes. For example, if you're using graph databases, nodes like systems, data stores, controls, teams, and risk events. And four simple relationships. For example, users. A user uses systems. A system is protected by a certain set of controls. It's owned by a certain person. A vulnerability or a threat has been identified in a particular system. The entire power of this map is to grow every AI answer in real world context. When someone asks a critical question like, are we exposed if a model provider goes down? This system first pulls a relevant slice of the map. It then writes a narrative using these specific real system names, real data types, and real owners. And if the answer can't cite real context, you do not act on it. What kind of intelligence are we looking for? We need to provide plain English rules. We need to write rules for known bad behaviors that even a new hire can understand. For example, if an app outlines patent information and no output filter, it should create a high alert. These are rules that we need to put into the system and make the rules explainable so that anyone can read them and understand what's happening and what's expected. We need to define baseline normal behavior. We need to track the typical hours, usage volumes, and set combinations of key applications. If something departs significantly, say off hour activity or a new combination of steps, you flag it and saying that's odd. These are rules that help the risk intelligence decide what's odd versus what's expected. We do regular checkups, run routine automated tests, try to trick it with safe prompts, make it hallucinate, check for user biases, pin those safety scores right into the map next to each application. What this does is it helps you ensure that the output from the AI system is consistent and it is something that you can trust. The reports, the final, need to be like a news brief. Every single alert that goes out must answer what, where, when, why, and why it matters and who is affected. Include comparisons like 50 times more activity than yesterday and context like this app handles core financial data. We prioritize alerts based on that context. The same pattern is a hobby tool means watch. In a clinical app, it means act now. And it's not only about identifying risks, it's also about creating visibility. This is where we need to use common sense in assessing risk criticality. This is the formalization of context awareness. Two identical threat events can be harmless in one place and an emergency in another. We want the score to be context driven. For example, we ask questions like what kind of data is involved? How important is the app to the business? How many people would be affected? How strong are the current protections or the controls? We use classical impact multiplied by likelihood, but then we adjust the risk rating based on the current protections or the current risk exposure, which shows us the current life map. As the controls change, the likelihood impact change. This helps us being aware of the current risk. The action layer is about prescriptive guidance. An AI system creates a plan by creating the map. What control should be protecting this app? Why this should be turned on? It then drafts a to do list with owners and expected impacts on each step. It provides a specific step, not vague recommendation. It gives an actual checklist with names, settings, and switches. And how does it do this? Is with all the data that we just mapped in the previous steps, where we bring the data together in a structured format for the LLM, the underlying LLM, or the technology to get the context, to build these risks, to build these recommendations that then can be tracked for action completions. This all sounds like a future vision, but we can do this today because of three breakthroughs in applied AI that directly map to the AI risk intelligence. It's production ready embeddings. We can now use vectors to capture meaning. So whether a log says SSH open on 22 403 spikes or auth misconfiguration, the embedding models cluster them as the same kind of security issue. This makes finding similar incidents incredibly reliable and easy and production ready. The graph on the grounded retrieval, this is the key. The intelligence layer uses graph that is used to pull the exact systems, data classes, control owners, and relationships directly into the AI context. This dramatically slashes hallucinations and turns vague advice into specific cited guidance. Agent patterns and safety harnesses. We can use AI agents to propose steps, look things up, and even change things, but we put them inside a harness. They can only roll out behind a small canary, for example, without breaking other logs. We can now automate without fear with all the advancements. Put simply, vector similarity plus graph grounding or using graph relationships plus having harnesses or guardrails equals risk intelligence that is fast, contextual, and trustworthy. Let's look at two examples. First example is leadership questions. A leader asks, if our main AI model is unavailable today, what actually breaks? How does the system plan about going this? The system's response, the intelligence plane instantly pulls the map. 23 apps are affected, crucially. Four are critical, two touch patent data, one application touches financial data, and none of the four have a documented backup plan. The proposal system asks set up a backend model for those four critical applications. Add a thin abstraction layer for easy switching of context. Run a monthly bake-off or run a monthly check-off comparing providers on quality, safety, and cost. The outcome is clear. We get cited answers within minutes, not days or weeks. We have no longer to wait for an analyst to go fetch data from unstructured data and bring it together. What we get is quick responses. Second example, a developer opens a pull request. Let the medical bot read lab result is the request. System checks the map. The system sees that the database contains patient information. The app is high impact and thousands of clinicians use it. It runs a what if analysis. It does all this in the engine. The risk goes up unless we add protections, and then it gives you plans or recommendations of what protections to add. For example, turn on the extra output check for patient info. Make sure that a threat actor is not able to pull that information while using the application. Require a purpose tag when the app reads lab results so that you can get authentication on what actions need to be taken. And at the end, we use all of this information to understand how the risk goes down. The human reviewer can instantly say, not yet, do these things before we can actually let you go forward and implement the necessary controls or the necessary features to in order to make the product more usable by the vendor or by the users. And finally, what does the risk intelligence tool really do? This new approach delivers what we need. It reduces time to decision. Measurements are in minutes, not days or weeks. It helps us identify blind spots. They probably are zero because all of the data is not bought now. Unstructured data is brought together, structured in relationships, so that it looks in each nook and corner to identify where the different contexts would help us identify risks. And with context driven data, it increases traceability. It gives us 100% clear evidence along with details that you understand to go backtrack to decisions, go backtrack on how the risk assessment was performed and what context was provided. The age of static spreadsheets is over. The time for living continuous AI risk intelligence is now. And this is my topic. And thank you so much for listening.